Hello friends, I am Dr. Prof.Chishty and I am teaching physics to BSc third year. My today's topic is Schrodinger wave equation, and that Schrodinger wave equations are of two types. First is time dependent Schrodinger equation and another is time independent Schrodinger wave equation. So today we are going to study about the Schrodinger time independent equation, time independent Schrodinger wave equation. So friends, we know that the Schrodinger time dependent equation, Schrodinger time dependent equation is given by minus h cross square upon 2m dou 2 psi by dou x square plus v psi is equal to ih cross dou psi by dou t. In terms of x and t, this equation can be rewritten as minus h cross square upon 2m dou 2 psi by dou x square x comma t, means the value of psi varies with the displacement and the time. So this equation will be in terms of x and t. Now we can say that when the potential energy does not depends upon the time, when the potential energy does not depends upon the time and the total energy is remaining constant, then the wave function psi will be written in the form of x and t. Will be written in the form of x and t. So let us say that the wave function psi is the function of psi of x, means the position, and the function of time. Therefore we can say that the psi of xt is equal to psi of x into f of t, where f is function of time. Or you can say that this psi is equal to psi f. Remember that this psi is capital psi. The psi which we are using here is also capital psi. The psi which we are using here is a psi. Okay. And here this psi depends upon the value of x and t. So here the notation is psi of x. This psi of x is different than this psi of x. So therefore this psi of psi is equal to psi f. Now I will differentiate this. With respect to x first. We are differentiating this psi is equal to psi of f with respect to x, partial differentiation. Therefore dou psi by dou x will be equal to, this function depend upon the time, therefore it will remain constant, means it is constant. Therefore f is constant and derivative of psi is dou psi by dou x. This is the capital psi and this is a small psi. So f into dou psi by dou x for our understanding. Now again I will differentiate it second time, second derivative. So you will get here dou 2 psi by dou x square is equal to f into dou 2 psi by dou x square. Okay. And if suppose I differentiate this equation number suppose 2 with respect to t. First I differentiated it with respect to x. Now I will differentiate it with respect to t. So I will get here dou psi by dou t is equal to psi as it is into dou f by dou t. Now here this psi will become constant when we are differentiating with respect to time. But we know the value of psi. As a into e raised to I by h cross px dot x minus e into t. In our previous lecture, we know this value of psi as a wave function. Therefore, if I differentiate this psi here, then a is constant, then power times means I h cross e raised to power I by h cross will remain as it is, px dot x minus et remain as it is, into the differentiation of this bracket. Differentiation of this bracket is only e, so I will multiply by e. Okay, remaining I by h cross remaining as it is. So I can write here that dou psi by dou t is equal to minus I by h cross e psi. Or we know that in terms of the function f, dou psi by dou t is equal to minus I by h cross e psi into f, Now put these values in equation number 1 here. I will substitute the value of dou 2 psi by dou x square. I will substitute the value of dou psi by dou t here in this equation. Now you will get minus h cross square by 2m as it is. Now for dou 2 psi by dou x square, I am writing here this value. Okay, dou 2 psi by dou x square is equal to f into dou 2 psi by dou x square plus now v as it is, and for this psi I am substituting here the value psi of f. Okay, so it will become v f psi is equal to, now for another side it will be ih cross into that value of dou psi by dou t. Value of dou psi by dou t is taken from here. That value of dou psi by dou t is minus I by h cross e psi into f. So I will substitute here. So what I have done here, remember that in time dependent Schrodinger equation, we use the time dependent Schrodinger equation, and in this Schrodinger equation we calculated the value of dou psi by dou t, this value, and we calculated the value of dou psi by dou t by using the function of psi as the function of psi x and ft, this function. Okay, now using this function, that the psi is a function of psi of x and f of t, or simply we can write psi is equal to psi f. Okay, then I differentiated this for the first time with respect to x, differentiate with respect to x, then double derivative dou 2 psi by dou x square is equal to f into dou 2 psi by dou x square. I have taken the double derivative. It means that we got this value. Okay, then I differentiated this equation, this equation with respect to t, so that I can replace this value. Therefore dou psi by dou t is equal to psi into dou f by dou t. But this value of psi is a into e raised to power I by h cross p of x dot x minus e into t. So if I am having this value and I am differentiating it, then dou psi by dou t is equal to minus I by h cross and this value, or dou psi by dou t is equal to minus I by h cross e into this complete is psi. It is psi. So I am substituting here as psi. Therefore dou psi by dou t is equal to I by h cross e psi into f. Okay, where f is a function. So I can substitute here these values in this equation number 1, and I will get this equation in terms of minus h cross square upon 2m f into dou 2 psi by dou x square plus v f psi is equal to ih cross minus I by h cross e psi into f. Now I will divide the equation by f. So I will get here minus h cross square upon 2m dou 2 psi by dou x square plus v psi equal to e psi. Now take this e psi to this side, it will become v minus e, psi will be common, and our equation will become h cross square upon 2m dou 2 psi by dou x square plus E minus V psi is equal to 0 because I am inserting this negative sign into this bracket. Again by multiplying by minus sign. So you will get dou 2 psi by dou x square is equal to 2m by h cross square E minus V psi is equal to 0. In the finite terms, this equation can be written as d2 psi by dx square plus 2m by h cross square E minus V psi is equal to 0. Now I am multiplying here, I am eliminating this h cross square upon 2m by multiplying complete equation by reciprocal of this as 2m by h cross square, 2m by h cross square. So this equation is called as Schrodinger's time independent equation, because in this equation I eliminated the term representing time. Therefore this equation is called as Schrodinger time independent equation. Thank you very much.